Hello children, today we are going to discuss chapter Matter in Our Surroundings, class 9. What is matter? Matter is anything which occupies space, has mass and can be felt by any of our five senses like air, water, hydrogen, oxygen, etc. All living, non-living things are made up of matter. The smallest constituent of all matter is atom, and it is made up of five basic elements. These are called panch tatva: air, earth, fire, water, and sky. These are five basic elements from which everything in this universe is made up of. Modern scientists classify these elements on the basis of two properties, that is physical classification and chemical classification. Physically, if we classify matter, it can be classified as solid, liquid, and gases. And chemically, these can be classified into elements, compounds, and mixture. Abstract things like love, respect, hatred, friendship, these are not coming in matter. What is physical nature of matter? Matter is made up of particles. Everything that is present in this universe is made up of very small tiny particles, and these tiny particles are called atoms. Atoms combines to form molecules, and these are constituents of all matter present around us. When you dissolve something, like you are having a beaker full of water and you are taking 2-3 crystals of potassium permanganate, you dissolve in it, what happens? Whole solution turns pink in color. If you are taking 2-3 drops of blue or red ink and you are dissolving that ink into a glass of water, whole water turn colored. Why so? Because it is miscible, they get mixed up. Where this sugar or salt or ink you are dissolving in water is going, it is going into the interparticle spaces. Like if you are taking a glass of water and you are marking the level till which water is present, and then you put 2 spoons of sugar in it, initially the level will rise. Then you dissolve it well, then level will again come back to its initial position. Where sugar is going? Sugar is going into the interparticle spaces of water. Means the vacant spaces which are present in water molecules are now covered up by the solute that you are dissolving in it. When you are mixing two gases, then what happens? If you are having a gas jar of hydrogen, another gas jar of bromine gas, you are mixing them, what happens? These gases mixed up very quickly. Why so? We know that gases particles are having more energy, more kinetic energy, and their mixing is very fast. The rate of diffusion in case of gases is very fast. You will see that the brown color of bromine gas will start fading up and hydrogen gas is mixing up now with bromine, and you will get pale yellow colored mixture in this. In the process of diffusion, we know that tiny particles of matter are constantly moving. That's why they mixed up together. There is movement of pollen grains in water. You can see that Robert Brown, he found that pollen grains in water, they are present and they are moving at constant speed. Means the smaller particles which are present in water are in random motion. They are in zig-zag motion. That motion is called Brownian movement. Because of that, the tiny particles are constantly moving. You can see अगर एक room है उसमें एक छोटा सा pin hole है, very small hole is there, and from that hole sunlight is coming. You can see the way of light, it is coming. तो क्या होता है, canopy बन जाती है. ठीक है, in that canopy you can see the dust particles how they are moving, and this canopy you can see in dense area ऑफ फॉरेस्ट ऑल्सो, जहाँ पे बहुत सारे ट्रीज होते हैं और उनके बीच में थोड़ी थोड़ी स्पेसेस होती हैं, वहां से सनलाइट आती है तो ऐसे स्कैटर होके आती है. यू कैन सी दैट कैनोपी ओवर देयर ऑल्सो. And when you are dissolving in ink in water, you can see there is dissolution of ink by a random motion. तो water के अंदर जो particles हैं वो constant नहीं हैं, they are in motion. That's why ink is dissolving in water in a random manner. That you can see when you are adding 2 drops of ink in a glass of water. तो वो zigzag motion जो show करता है, that is Brownian movement. Particles of matter are made up of very small tiny particles that are atoms, and atoms combines to form molecules. Matter is having spaces between them, that's why solubility is there, and we can dissolve something in liquids. Particles of matter are constantly moving, that we know, that we have seen in Brownian movement also. Particles of matter attract each other. This thing we can prove when you are taking a sample of gas and you are just applying high pressure on it, that gas particles are coming closer to each other. When you are reducing its temperature and you are increasing pressure, the gas molecules, they are condensing, they are forming liquid. So gas को compress कैसे कर सकते हैं, gas को liquefy कैसे कर सकते हैं? You need two conditions. You have to apply high pressure and low temperature, then only gas can be converted to liquid. Why gases are able to turn into liquid? Reason is the particles of gas are having forces of attraction between them. अगर उनके बीच में कोई फोर्स ऑफ अट्रैक्शन ना होती तो प्रेशर अप्लाई करने पे, लो टेम्परेचर अप्लाई करने पे भी वो क्लोजर ना आते एक दूसरे के. Why they are coming closer to each other? Because of the force which is present between them. Particles of matter have spaces between them. You can see when you are taking sugar and you are dissolving in it water, sugar is going into the vacant spaces that are present between water molecules, and these are called interparticle spaces. Particles of matter are constantly moving. आप एक इंसेंस स्टिक लेते हैं, अगरबत्ती लेते हैं, उसे कॉर्नर में जला देते हैं रूम के, तो क्या होता है? वो अगरबत्ती जो है वो जलना शुरू होती है. द पार्टिकल्स आर गेटिंग काइनेटिक एनर्जी एंड दे आर मूविंग फास्ट. ठीक है, अगर किसी के घर में किचन में एक दिन मंचूरियन बन रहा है और दूसरे दिन उसी किचन में आपके चॉकलेट केक बन रहा है, तो मंचूरियन की स्मेल तो आपके रूम तक आ जाती है, चॉकलेट केक की स्मेल आपके रूम तक नहीं आती. रीजन बिहाइंड इज, व्हाट इज रीजन? Because hot food is having more kinetic energy. More is kinetic energy, so particle will reach to your nostril fast. और आप भाग के आओगे, मम्मा आज क्या बनाया है ना. तो what is reason behind it? Because the particles are having more kinetic energy. हॉट फूड की स्मेल आपके नोस्ट्रिल तक जल्दी पहुंचती है एज कंपेयर टू कोल्ड फूड, बिकॉज द हॉट फूड इज हैविंग मोर काइनेटिक एनर्जी, सो मूवमेंट विल बी फास्ट. You can do this experiment with ink also. You can take 2 beakers with cold water and hot water and two drops of ink in it. You will find that in cold water ink will take more time for dissolution as compared to hot water. As in hot water, particles are having more kinetic energy, they will mix up fast. Particles of matter attract each other. In case of solids, particles are tightly bound. They are having more forces of attraction between them. In case of gases, forces of attraction are minimum. And in liquids, it is moderate. In case of solids, we know solids are having fixed shape, fixed volume. They can't be compressed much. They are having high density. They are heavy. And they don't fill the container completely. If you are having 1 kg of sugar and you are putting in a container which can have 2 kg of sugar, तो half ही fill होगा, वो उसको पूरा नहीं भर सकता जैसे gases कर सकती हैं. Solids don't flow. We call liquids and gases as fluids. Why fluids? Because they can flow, and solids, they can't flow. Then we have properties of liquids. Liquids have fixed volume, but they don't have fixed shape. Means you can take any vessel and put liquid in it. That liquid will acquire shape of that container in it. You are having 1 liter of milk and you are putting it in different containers. It will stay 1 liter only, but its shape will change according to the vessel in which you are putting it. In solids, like solids, liquids can't be compressed much. आप प्रेशर अप्लाई करोगे तो उस पर कुछ ज्यादा फर्क नहीं पड़ने वाला. Liquids have moderate to high density. They are usually less dense than solids. Liquids don't fill the containers completely, and liquids generally flow easily. In case of gases, gases neither have fixed shape nor fixed volume. Gases acquire the shape and volume of vessel in which they are kept. आप किसी भी कंटेनर में गैस को फिल करोगे, उस पूरे कंटेनर को वो फिल कर लेगी. Gases are having random movement. Gas particles are in random motion and they will apply pressure on the walls of container. Gases can be compressed easily by the application of high pressure and low temperature. You can compress a gas to form liquid. Gases have low density as the particles are very far away placed from each other, so they are having lesser densities. Then gases can fill the container in which it is kept. Gases can flow easily from one place to another. And we are using most of the gases in the form of compressed gas. Means you have to compress it in the cylinder and then we are using. Like in cooking gas, we are using liquefied petroleum gas. That is LPG. Oxygen gas is supplied to hospitals in the form of liquid gas. Then compressed natural gas we are using to run vehicles, CNG. Major component of CNG is methane and major component of LPG is butane. These gases have to be compressed so that we can keep it in a lesser place. Then what is diffusion? Diffusion means mixing. When particles are mixing up together, that is called diffusion. In case of gases, rate of diffusion is fastest, and in case of solids, rate of diffusion is very slow. आपने कभी देखा होगा कि बोर्ड पे आपने कुछ लिखा, ग्रीन बोर्ड या ब्लैक बोर्ड जो भी होता है स्कूल में, उसमें कुछ लिखा हुआ और बहुत दिन तक लिखा रह गया, ठीक है, 15-20 दिन लिखा हुआ है, उसके बाद उसे डस्टर से रब करते हैं तो वो साफ नहीं होता, क्या होता है, वो अंदर तक चला जाता है उसके. दिस इज बिकॉज ऑफ डिफ्यूजन, राइट. Chalk has diffused into the pores of that board. That is diffusion. Rate of diffusion increase with increase in temperature. गर्म खाने की स्मेल आप तक जल्दी पहुंचती है as compared to cold food. That is because of rate of diffusion increases on increasing the temperature. The phenomenon of diffusion tells that particles of matter are constantly moving. Particles are moving, that's why that smell is reaching to you, like smell of perfume, smell of incense stick. It is reaching to your nostril because particles are in motion. In case of liquids, rate of diffusion is faster as compared to solids, but it is lesser than gases. In gases, rate of diffusion is maximum. Like spreading of purple color of potassium permanganate into water is example of diffusion that you have seen. Or you have taken 5-4 crystals of copper sulfate and you have dissolved it in water to attain blue solution. That is also example of diffusion. Then spreading of ink in water is also diffusion. Along with that, the most important diffusion is oxygen gas is dissolved in water. Aquatic animals, aquatic plants, they are breathing inside the water because of that dissolved oxygen. They are using that dissolved oxygen. The property of dissolution of oxygen gas into water is so important that whole aquatic life depends on it. In case of solids also, diffusion can be seen, but the process of diffusion is very, very slow. That is again the example which is given here is of board only. And if two metal blocks are kept undisturbed for some time, then you can see that diffusion in them at very slow pace. Then you have to convert temperature is having different units and you have to convert from one unit to another. Like we are having degree Celsius, we are having Kelvins. These are the scales in which you have to convert from one to another. SI unit of temperature is Kelvin. And the temperature at which one state is changing to another, that is special temperature we need to learn. Like at 0 degree Celsius. 0 degree Celsius is the temperature at which ice is turning into water and water is turning into ice. Means it is freezing point of water and melting point of ice. 0 degree Celsius is freezing point of water and melting point of ice. 100 degrees Celsius is again a transition temperature at which liquid water start turning into the vapors. So it is temperature which is called boiling point of water. 100 degrees Celsius is boiling point of water and condensing point of water vapors to again form water liquid. And we can have a conversion formula. 0 degrees Celsius is equal to 273 Kelvin. So if you want to convert these temperatures into Kelvin scale, you just add 273 and it will turn to Kelvin scale. Like here we are having 25 degrees Celsius. When we are adding 273 in it, it will give you 298. So it is 298 Kelvin. 25 degrees Celsius is equal to 298 Kelvin. Then if you are having temperature in Kelvin scale and you want to convert it into back degree Celsius, then you have to subtract 273. It will give you value in Celsius scale. Change of state of matter means ice can convert into solid, water can convert into liquid, water vapors can convert into gas. Means if you are having solid, like you are having ice, and you are converting it into liquid, that is, solid can convert into liquid by the process of melting, and liquid can be converted back into solid by the process of freezing. Similarly, liquid water is converting into gas by the process of evaporation or boiling, and gas can be condensed to form back liquid. And if you are having gaseous state, means you are having water vapors, it can convert into gases, can be converted into solid. If you are having camphor, you are having iodine, if you are having anthracene, all those substances which can sublime. So in that case, gases can be converted to solid, and solids can be converted into gases by the process of sublimation. Then we can have effect of temperature. First is solid to liquid change, that is called melting. Ice is changing into liquid water by the process of melting. As we heat any solid, the kinetic energy between the particles of solid increases. That means particles will start moving away from each other, and the energy with which you are heating it is transferred to that particular solid, and it is now turning into liquid state. The temperature at which it starts turning into liquid is called its melting point at normal atmospheric pressure, that is at 1 atmosphere. For example, melting point of ice is 273.16 Kelvin, and the process is called melting. Then we have liquid to gas change, that is called boiling. Boiling is also called vaporization. When you are converting a liquid into gas, means again you are giving them heat, and that heat is used to break the bonds which are present between them, and now the particles are moving away from each other. Now they are freely moving, they are having more random motion. That's why they are moving away from each other, and the temperature at which liquids start boiling is called boiling point, and the temperature for water is 373 Kelvin. Then we have gas to liquid change. It is called condensation. Condensation means when you are cooling down a gas to form liquid again. That is called condensation point. Then liquid to solid change, that is freezing. If you are having water, it is freezing to form solid. This heat is not shown by thermometer. In this case, it is called latent heat of vaporization. The amount of heat which is used to convert 1 kg of water at normal atmospheric pressure into its vapors is called latent heat of vaporization. Then we have latent heat of fusion. Latent heat of fusion is amount of heat that is required to change 1 kg of solid into liquid at atmospheric pressure. It is called लेटेंट हीट ऑफ फ्यूजन. मीन्स आपके पास 1 kg आइस है और उसको आपने लिक्विड वाटर में चेंज करना है. द अमाउंट ऑफ हीट विच इज यूज टू कन्वर्ट 0 डिग्री सेल्सियस की आइस को 0 डिग्री सेल्सियस के वाटर में चेंज करने के लिए जितनी हीट देनी पड़ेगी, दैट इज कॉल्ड लेटेंट हीट ऑफ फ्यूजन. When a solid melts, its temperature remains same because of this latent heat of fusion, right? Like you are having a piece of ice and you are having just ice cold water. दोनों का टेम्परेचर 0 डिग्री सेल्सियस है, बट 0 डिग्री सेल्सियस की आइस ज्यादा कूलिंग करती है एज कंपेयर टू 0 डिग्री सेल्सियस का वाटर, बिकॉज इट कंटेन्स एक्स्ट्रा latent heat of fusion in it. देन लेटेंट हीट ऑफ वेपराइजेशन, 100 डिग्री सेल्सियस के वाटर को 100 डिग्री सेल्सियस की स्टीम में चेंज करना है फॉर 1 kg ऑफ लिक्विड, राइट? यू आर हैविंग 1 kg ऑफ वाटर, 100 डिग्री सेल्सियस के वाटर से 100 डिग्री सेल्सियस की स्टीम बनानी है. दैट अमाउंट ऑफ हीट इज कॉल्ड लेटेंट हीट ऑफ वेपराइजेशन and its value is given here. That's why 100 डिग्री सेल्सियस के वाटर से 100 डिग्री सेल्सियस की स्टीम ज्यादा सीवियर बर्न कॉज करती है बिकॉज इट कंटेन्स एक्स्ट्रा हीट इन द फॉर्म ऑफ लेटेंट हीट ऑफ वेपराइजेशन. Then we have sublimation. Sublimation means changing of solid directly into vapors on heating and vapors into solid on cooling. We have some substances like we have ammonium chloride, iodine, camphor, naphthalene, anthracene. All these substances, even solid carbon dioxide, that is dry ice. They all are subliming, means they are converting from solid to vapors and vapors to solid without converting into liquid state. Reason behind them is in those cases like we are having naphthalene balls. तो क्या होता है, naphthalene balls का जो melting point है, it is more than its boiling point. That's why melting होने से पहले boiling point आ जाता है and it is converting into vapors. तो हम एक सीजन में कपड़े रख के उसमें नेफ्थलीन बॉल्स डालते हैं, नेक्स्ट सीजन में हमारे पास वो बॉल्स गायब होती हैं. इट इज नॉट लिविंग एनी रेजिड्यू आफ्टर देम. Then what is effect of change of pressure? With the change of pressure, what happens? Physical state of matter can be changed, like gases can be converted into liquids by the application of high pressure and low temperature. This can be seen in many cases like nitrogen, liquid nitrogen we are using. Then we have evaporation. Evaporation is process of changing of liquid into vapors below its boiling point. राइट, नॉर्मली जो लेक्स हैं, वाटर रिसोर्सेज हैं, उनसे जो वाटर है वो इवेपोरेट होता रहता है, उनका टेम्परेचर कभी भी बॉइलिंग पॉइंट पे नहीं पहुंचता. तो नॉर्मल, दिस इज नॉर्मल डे टू डे एक्टिविटी जिसमें वाटर लिक्विड से वेपर्स बन रहा है. यू हैव सीन दिस इज रीजन ऑफ वाटर साइकिल. This is called evaporation. Wet clothes dry because of evaporation. Rainwater is changing into vapors. Common salt can be recovered from seawater by the process of evaporation. Then we have four major factors that affects the rate of evaporation. First is temperature. गर्मियों में कपड़े जल्दी सूखते हैं. Reason is because increase in temperature will increase the rate of evaporation. Particles will get more kinetic energy, so उनका rate of movement fast हो जाता है. Then surface area of liquid. Surface area जितना बड़ा होगा उतना rate of evaporation fast होगा. Like आपके पास एक glass water है, आपने पहले ग्लास में रखा, फिर आपने एक बड़े कंटेनर में, एक बड़े थाल में डाल दिया, तो क्या होगा, रेट ऑफ इवेपोरेशन इंक्रीज हो जाएगा. दैट्स वाई आप क्लोथ्स जो हैं उनको खोल के वायर्स पे डालते हो. उसका रीजन क्या है? So that they can dry fast. Rate of evaporation will increase. Then humidity in air. If humidity is more in air, then rate of evaporation will be less. If humidity is less, then it is having more power to gain water molecules. That means rate of evaporation will be fast. If wind speed is more, then rate of evaporation will be fast. Wind is blowing at fast speed, that means it will take more water molecules with it. Rate of evaporation will increase. Then cooling caused by evaporation. आपके हाथ पे 2 ड्रॉप्स एसीटोन डाल दिए. एसीटोन इज अ वॉलेटाइल सब्सटेंस, उसके वेपर्स बहुत जल्दी बन जाते हैं, तो आपको बहुत ठंडा फील होता है. सेम थिंग इज नेल पेंट रिमूवर. तो आपने नेल पेंट रिमूवर के 2 ड्रॉप्स हाथ पे डाल दिया, आपको ठंडा फील होता है. वाई सो? द पार्टिकल्स विच आर लीविंग फ्रॉम द सरफेस नीड सम एनर्जी. तो जो एनर्जी सरफेस से लेके जाएंगे, ठीक है, वो सरफेस से कुछ एनर्जी लेके जा रहे हैं, तो जिस सरफेस से एनर्जी लेके जाएंगे उस सरफेस को ठंडा करेंगे. The particles for their motion needs kinetic energy which they are taking from your palm in the form of heat energy. That's why आपके हाथ को ठंडा फील होता है. We are able to have hot tea from a saucer rather than a cup. कप का सरफेस एरिया कम होता है, सॉसर का सरफेस एरिया बड़ा हो जाता है, तो रेट ऑफ इवेपोरेशन विल बी फास्टर, तो ठंडा जल्दी हो जाता है. दैट्स व्हाई वी हैव टी फ्रॉम सॉसर अगर जल्दी होती है तो. Then we sweat more in summers. Why so? We are feeling cold. तो evaporation होती रहेगी sweating की, तो आपको comfortable feel होगा. That's why we are wearing cotton clothes in summers, because they are having small pores in them. तो उनमें से air cross करती रहती है, आपका sweat evaporate होता रहता है and you feel comfortable. There are water vapors present in air. अगर आपने एक chilled कोल्ड ड्रिंक ग्लास में डाल दिया या आपने आइस ग्लास में डाल दिया और थोड़ी देर छोड़ दिया, यू कैन सी वाटर ड्रॉपलेट्स ऑन द आउटर सरफेस. कहाँ से आए वो वाटर ड्रॉपलेट्स? तो एयर इज स्ट्राइकिंग विद इट, एयर इज containing some water molecules. When they strike with that glass, तो वो water droplets उस glass के surface के साथ stick कर गए. Means the vapors which are present in air are condensed, that you can see on the walls of glass. Then we have two more states of matter. First is plasma state. प्लाज्मा स्टेट इज सुपर एक्साइटेड, सुपर एनर्जेटिक स्टेट. होता क्या है, जो आपकी नोबल गैसेस हैं, जो ट्यूब के अंदर नियॉन गैस फिल करी हुई है, कैथोड्रे एक्सपेरिमेंट में भी पढ़ा था कि वो आयंस में ब्रेक हो जाती है. ठीक है, तो जब वो आयंस में ब्रेक होती है, आयनाइज्ड फॉर्म में उस ट्यूब के अंदर प्रेजेंट होती है, व्हेन यू आर पासिंग इलेक्ट्रिक करंट थ्रू इट, तो इट ग्लोज, राइट? बिकॉज द आयंस विच आर प्रेजेंट देयर, they glows and they are containing a plasma inside them. Because of that, this tube light glows. Then we have Bose-Einstein state. Bose-Einstein state is fifth state of matter, and it is formed by condensing of gases with extremely low density and at lower temperature. That's all about this chapter. Thank you.